Hello students. Now in this video I am going to discuss about the second application of the dimensions. In first application we have seen that how the correctness of the relation can be get done. But in this application we will discuss how a formula can be get derived. For example, let us say we have to derive the expression for time period of a pendulum. Time period of a pendulum. On what factor it depends and what could be its formula. Time period of the fan. Now let us say we know that time period depends upon mass of the bob. Bob is a substance like this one, so this is a bob. On it depends. Second, it depends on the length of the pendulum, means for how long the pendulum is being there. So that is, this is the length and this is the mass, all these things. And third, it depends upon the gravity. Gravity basically is the acceleration due to gravity, so it is g. So, and fourth is the angle of swing or angle of swing, so how it depends upon them. So all these factors will depend. So that means we will write this relation as time is directly proportional to m raised power a, then it is l raised power b, then g raised power c, and theta raised power d, and where a b c d are the subscripts of the powers, and time we have to find the dimensions. Now we will remove this proportionality. Let us say it is k, so which is equal to k into m raised power a, l raised power b, g raised power c, and theta raised power d. So all this is the expression which we are going to get. Now what we have to do, we have to get the values of a, b, c, and d. How we can do it? By taking the dimensions of this side, and then compare the values of mass, length, and times, and we can get the values of a, b, and c. So let us do it one by one. Now let us start for LHS. LHS is a time period and it has dimensions of m0, l0, t1. So only this kind of dimensions is there. Now RHS consists of mass, length, gravity, and theta. So we have to put the values of all these one by one. Now we are going to take for mass. Now the dimensions of mass is m1, l0, t0. Now this is the dimensions of mass. Now m raised power a means m1, l0, t0 raised power a, or I can write it as ma, l0, t0. And then second was length. Length has dimensions of m0, l1, t0, or L has power of b, so it will be m0, l1, t0 raised power b. So it will be equal to m0, lb, t0. So that is the dimensions of b. Then we have got g, that is m0, l1, t minus 2. So that is acceleration due to gravity. gc, so it will be m0, l1, t minus 2 raised power c. So we will get here m0, lc, t minus 2c. So this is the third one. Then theta. Theta has no dimension, l0, t0. So theta raised power d is m0, l0, t0. Now all the four dimensions we have find it out. Now we will take the RHS clubbed side. So first part we will take ma, l0, t0. Second part, and that will be m0, l1, t0. Third part, m0, lb, t0. And third part, m0, lc, t minus 2c. And fourth part, m0, l0, and t0. So all these fourth part were there. Now we will club the four part. Now first example, mass a, here 0, here 0, here 0. So we can write it as m raised power a. L 0, b, c. Now L raised power b plus c. Now time, it will be 0, 0, minus 2c, minus 2c. So now this we have got the dimensions for the right hand side. Now we have to compare it with the left hand side, which was equal to of m0, l0, t1. Now compare the subscripts. We will see a comes out to be 0. By comparing, we get a raised power 0, and then b plus c is also equal to 0, and then third is minus 2c is equal to 1. minus 2c is equal to 1. So that means, so what you will get, a is equal to 0, b is equal to minus c, and c is equal to minus half. C minus half, then b is equal to half. So that means time period depends upon m raised power 0, and d does not have also no value, so d is also have no value, d is 0. So l theta raised power 0, and then l raised power b 1 by 2, and then g raised power minus 1 by 2. So that means it is proportional to m0 is 1, it is 1, so l upon g under root. So t is proportional to under root of l by g, or we remove the constant, so we can write it as 2 pi under root of l by g. So this is the way we can able to derive the relationship using the dimension analysis. So this is a very important techniques where we can able to measure the dimensions by comparing different quantities, left hand side and right hand side, and then compare the unknown constants, and then solving those equations, and we can get the final result. So this is a second application. Thank you.